So I'm going to solve problem 49 for you. We've already done the free body diagram together, so I'm just going to keep that one and kind of go from there. So what do we have? What do I know? I know mass 1. Pardon me, just got to grab my book. Mass 1 is 5 kilograms. Mass 2 is 9 kilograms. And the coefficient of kinetic friction is 0.2. Oh, they actually only want the tension and the strain. But we're going to find out we're going to need to find the acceleration of the system anyway. So there we go. So here we go. I'm just going to use my system analysis. For sum of forces of the system in the x direction is mass of the system, A cis x. And here we go. Let's see. So what's that? I've got negative fk1 plus t2 comma 1 minus t1 comma 2 plus fg2 equals m1 plus m2 a cis x. I'm going to box these two because I know that they go to 0 as a grouping because of Newton's third law. I see the friction there, so I'm going to come over here on the side. Sum of forces in the y dimension on object 1 is equal to mass 1a 1y, because Fn, that should be Fn1, excuse me, Fn1 minus Fg1 is equal to m1a1y. a1y goes to 0 because it makes no sense for that thing to sink into the table or fly off the table. Therefore, Fn1 equals m1g, and therefore Fk1 is equal to mu k m1g. So then doing all this out, solving for a cis x equals, and it looks like m2g minus mu k m1g all over m1 plus m2. And I can solve my numbers in there, so might as well do that. 9 kilograms, 9.8 newtons per kilogram, minus 0.2, 5 kilograms, 9.8 newtons per kilogram, all over 5 kilograms plus 9 kilograms. I'm going to throw that into our calculator. 88.2, I'm just stealing some numbers in case they end up being useful later. I don't know why they would be, but 24.5 all over 14. Okay, and that's 4.55 meters per second positive. Right, so then I want the tension, so now I have to do a sum of forces equation. I can do it. I think mass 2 is the easiest mass to do. M2A2X. So that's going to be Fg2. Oh, good. I stole that number. So I have that number here. Minus T1 on 2 is equal to M2A2X. So 88.2 newtons minus T2 on 1 is 9 kilograms times 4.55 meters per second squared. There we go. Times 9. Okay. And I got T1 on 2 is equal to 47.25 newtons. Whoops. Sorry about that, folks. A little too emphatic with finishing that problem out. My phone fell off. All right, so there we go. And there is that problem. Now, I'm going to ask you to take a look at that in a couple of minutes. We're going to come back and talk about that. All right, let's do another problem. In this problem 34. And if you look at problem 34, it is an inclined plane, pulley, and 2 masses. So it looks very familiar compared to the other problems that we just did. Just the inclined plane is the only new wrinkle there. And this is called mass 1. This is called mass 2. That is theta. We're told a whole bunch of stuff. So we want to know, once again, the acceleration of masses, the tension of the string, and the speed after 2 seconds. All right, cool. So once again, free body diagram. Starting with Fg1 And once again, we're going to go T2 on 1. We don't have to do, because we're going to assume all of our pulleys are frictionless and massless unless we're told otherwise. T1 on 2. And now I can do Fn2, Fg2. And this is a frictionless plane as well. So we don't have to worry about that on the inclined plane. Step 2, axes and declaration. I'm going to just do this. And now actually, I'm going to look at the two masses. M1, the one off the edge, is 2 kilograms. M2 is 6 kilograms. I think this might actually go down this way. So I'm going to make this my positive x and that my negative x. And then this becomes my positive y over here. Not that I'm going to care about the normal force once again because there's no friction, but there it is. So I get Fg2y and Fg2x, and I know that this angle there is that angle there. So perfect. I've got my free body diagram set up, my axes. Let's see what I know. Like I said, mass 1 is 2 kilograms, mass 2 is 6 kilograms, theta is 55 degrees. Right, so I'd probably just start putting in the numbers pretty soon here, but I'm going to do this algebraically first because, once again, I want to make a larger point. But there's no point in not just starting to calculate like FG1, FG2, FG2x, FG2y, etc. if you want to just do some side calculations. But I'm going to go right to sum of the force of the system in the x dimension is equal to mass of the system, A cis x. Starting here, I have a negative Fg1 positive T2 on 1, once again minus T1 on 2, and then plus Fg2x equals M1 plus M2 A cis x. And once again, that whole grouping is going to go to 0 because of Newton's third law. I'm being really explicit about it. So here we go in variables, M1, negative M1g plus M2g sine theta is equal to, oh, actually, let's just move the M1, M2 over to the other side. There you go. And that's it. And I can plug in and solve for A cis x now. So let's actually do the numbers. A cis x equals negative 2 kilograms times 9.8 newtons per kilogram plus 6 kilograms times 9.8 newtons per kilogram sine of 55 all over 2 kilograms plus 6 kilograms. Okay, negative 19.6. I can take a guess at what that is, but I'd rather just get the number. Okay, plus 48.2 all over 8, and that's going to give us 3.57 meters per second per second. There you go. All right, and that means it's gonna, the 2 is gonna go downslope and 1 is gonna move up as a result. And then to find the tension, once again, I would come back over here. I'm not, and just, well, as well, by the time I just describe what to do, I can just do it. F1x, some force F1x, M1, A1x, and that's gonna be equal to T2, 1 minus Fg1 is equal to M1, A1x. T2, 1 minus 19.6 newtons, because I stole that from down there, is 2 kilograms times 3.75 or 57 meters per second. T21 is equal to 26.7 newtons, and there you go. Okay, now that larger point I wanted to make. I want to look back at the 3 different A cis x equations I had. So for the first system, A cis x was F over that. For the second system, A cis x was the weight of the second object minus the friction over that. And now the third one is the x weight of this minus the weight of that over M1 plus M2. And what I want you to see here is, well, what is the denominator in each time? The denominator in each time in these system equations is going to be the total inertia of the system. Mass is about inertia, and it's about inertia. And so with the numerator here is, if you think about that x-axis, if I were to unfold it, it's just the net force of all the forces acting along the x-axis with the connective tissue gone. That doesn't mean that I don't do this step and show the connective tissue going away, but it gives you a sense of an expectation for what you should get for each of these answers. 34, just to finish it off here, they want the speed after 2 seconds. I would just do VF is equal to VI plus AT. VI is equal to 0. A is 3.257 meters per second times 2. So kind of trivial there. So there you go. So just a little kinematics just to finish it up. So with that being said, there is systems problems connected by tensions.